So dear students, welcome to the part 3 of our lecture series of about zone refining method for single crystal growth. So in this lecture series we will discuss about the second type of zone refining method, which is known as vertical zone refining method for single crystal growth. As dear student, it is clear from the term vertical zone refining method, basically it's used a setup of in a vertical way. So the polycrystalline material is basically in vertical zone refining method is moved along the vertical direction and it is purified and converted into highly pure single crystals. The setup of vertical zone refining method is simply explained as schematic diagram as the zone refining um, setup consists of a zone refining furnace, which is this is the exterior region of the zone refining furnace. So this is the internal part of the zone refining furnace. In the internal part of the zone refining furnace, the polycrystalline material or the impure crystalline material is placed along the vertical direction of the zone refining. The polycrystal used in zone refining furnace is basically highly impure and it is placed in a vertically in the zone refining furnace, and this polycrystal is connected with a heating setup and like heating setup or a heaters, okay, like this. And these heaters are very sophisticated and they are very targeted, okay. They basically melt a small narrow region of the polycrystal which is placed vertically. So this heater will melt the polycrystal along the vertical direction like this. So this area, this schematic region, basically represent a melted area which is basically caused by the heater. As I previously discussed, there are different types of heating setup which can be used in zone refining method, but most commonly heating setup is basically optical heating setup, basically which melt polycrystalline materials. Okay, so as dear student, please note that the impurities, basically this zone refining method work on in the principle of the segregation coefficient, okay. So the impurities basically are transported into a melting region from the solid region, okay. The ratio of this solid region impurity diffusion from solid to a liquid is less than 1. So basically the impurities which are present in solid polycrystal will be transported into this melted region, and this melted region is full of impurities. Since the vertical zone refining method used movable types of heatings, and these movable heaters basically melt a narrow region. When the heaters moves, dear student, when the heaters moves the dear student, when the heaters moves like along moves above the region which is melted, basically will be transported like this above, and this region will be melted, whereas the region which was left below is basically, since the temperature is decreased, will be converted into highly pure single crystalline region, okay. So this region which is left is highly pure, okay. This is highly pure, whereas all the impurities will be transferred from this pure region into this highly impure region, okay. So like this. So this region is basically a highly pure single crystalline method. Now question is there, dear student, why the microelectronic industry is very less common to vertical zone refining method? Student, please note that vertical zone refining method has some issues, like heaters are moving here. It is quite difficulty for the diffused atom or impurity atoms to move completely or very easily along the upward direction. So due to this, zone refining method is rarely used in a single crystal. Vertical zone refining method is rarely used, and this is due to this, the horizontal zone refining method is more commonly used, okay. So in this way, dear student, though the vertical zone refining method is less used in microelectronics, but still we can get single crystalline material. So the heater will move again along the upward direction, and this like somewhere around here, the remaining region which was melted will be converted into highly pure region. Higher poly is single crystal, whereas the impurities will be transported somewhere around here. So in this way, basically we prepared a single crystal material in a vertical direction, and all the impurities will be collected somewhere here. Okay, so this region where the heater which is the ending region where the heating motion end basically is composed of maximum number of impurities, and it is chopped off, and the remaining part which is a vertical crystal, it is converted and it is basically a very highly pure single crystal. But this one, please note that the transportation of impurity, or the segregation, I will say segregation coefficient in vertical zone refining, is very closer to one, and it is quite difficult for impurity transport from a solid phase into a melt, because of the like additional uh, power which is required, or pressure or something required to move these atoms to the molten state. So due to this, because they are the crystal is along the vertical direction, so due to this zone refining method in a vertical way is less common in microelectronic industry, though it is important part of the for important type of the single crystal growth technique. So thank you for watching part 3 of our and final part of our lecture series about zone refining.